Okay. All right, so this chapter is about the second law of thermodynamics. It's a long chapter, so let me briefly summarize this chapter. Okay. So this is the zeroth law of thermodynamics says law of thermodynamics says if two objects are in thermal contact with each other and there is no net heat being exchanged, they're at the same temperature. Okay, so that's what the zeroth law says. It's intuitive, and you guys are all aware of it. That is, if two objects are at the same temperature, they will not exchange any heat. All right. Now the first law of thermodynamics. First law is says change in internal energy is equal to the change in internal energy is equal to the heat added to the system minus the work done by the system. Okay. So this is essentially a conservation of energy principle. Okay. With heat included. All right, now we're coming, this chapter we're talking about the second law of thermodynamics. Okay. Second law of thermo. Okay. Now the third law says, I'll write down the third law first. Third law just says one can never reach 0 degree Kelvin, absolute zero temperature. Okay. Now, what does the second law say? Okay. So first thing, you need a second law. You need a new law when the existing laws do not explain all phenomena. Okay. So the zeroth law just says that so when there are phenomena that cannot be explained by the zeroth law and the first law, you need a second law. Okay. So again, here I'm summarizing this chapter because it's a long chapter. And so second law introduces a concept called entropy. Okay. And entropy, what it does is it measures disorder in the system. Okay. And what it does is the following. Okay, so if you have, let's say this end of the room is hot and this end of the room is cold. Okay, what happens is heat flows from the hot end to the cold end. Okay. Now, the thing is, the first law, which is a conservation of energy principle, it says conservation of energy, when energy flows from here to here, the total energy of the system is the same. Or if the energy flowed from here to there, the total energy of the system would be the same. So even if heat flowed from a cold end to a hot end, the first law would not be violated. Okay. But in nature, we always see that heat flows from a hotter end to the colder end. So to account for this fact, you need the second law of thermodynamics. And the second law of thermodynamics postulates a quantity called entropy. And what the second law says is, so in this process, when heat flows from the hot end to the cold end, this is a naturally occurring process. What happens is entropy increases. Okay, entropy is denoted by S, and entropy increases. So that's what the second law says. Okay, so in irreversible processes, so this is what is called an irreversible process. Entropy increases. Okay. So what we're saying is, in nature, what we observe is that heat only flows from a hot object to a cold object. You never see heat flowing from a cold object to a hot object naturally, okay, on its own. So, and heat flowing from a cold object to a hot object would not violate conservation of energy principle, which is the first law of thermodynamics, okay? So the fact that we see this process occurring only in this direction requires the requires the need for a new law, which is the second law of thermodynamics. And the second law of thermodynamics describes this phenomenon by stating that this process occurs in this direction because entropy increases in that direction. Okay. So the second law says only in nature, processes that occur in nature involve increase in entropy, and only those processes occur in nature. So if in a process entropy would decrease, then that process would not occur. Okay, so that's the second law of thermodynamics. And again, we'll learn more details about this throughout the chapter, but I'm just summarizing this. Okay. All right. Another concept that we learn in this chapter is heat engines. Okay. Heat engines. And what do heat engines do? So heat engines, what they do is they take heat from a hot reservoir. So this is a hot reservoir. They take heat and convert some of that to work, and the rest of it is dumped out. Okay, dumped out because it cannot be converted to work. That's a heat engine. Your car, for instance, is a heat engine. In your engine block, you're burning air fuel mixture. That's the hot reservoir. You're getting some heat out of it, and you're converting part of that to the motion of the car, work, and the rest is dumped into that environment. Okay, so the rest. All right, so in a heat engine, you're getting heat, you're absorbing heat from a hot reservoir. Uh, 20%. Okay. What that means is for $4 of heat you get, you're able to convert $1 of it into motion of the car. And $4 is
Dr. Tosi, I think you're on mute.
Okay, how about now? Can you guys hear me now?
Yep.
Okay. All right. I guess I was trying to, I guess, I get some background noise from you guys, so you'll have to unmute yourself. Okay. Unmute all. I mean, mute yourself because I'm getting some background noise. Okay. So let's. Okay. So again, I'm summarizing this chapter because we have a lot of um, slides. So we were talking about heat engines, and the final topic is refrigerators. And what refrigerators do is they will take heat from a cold reservoir and dump it into a hot reservoir. Okay. Except that heat doesn't want to flow that way, so you have to do some work to do that. Okay. Heat doesn't naturally want to flow from a cold place to a hot place, and that's what a refrigerator does. So for instance, it removes heat from inside your refrigerator, which is colder, and puts it in the kitchen, which is hotter. Okay. And for that, you have to do work. Okay. So those are the three things we'll talk about. Okay. So again, let me summarize. Okay. So for instance, okay, again, so here's in a room, this end is hot, this end is cold. Again, so I've drawn two pictures, and the first law of thermodynamics, first law is a conservation of energy principle. Okay, in conservation of energy, if heat flowed in this direction, the total energy of the system is still constant. Okay, but in nature, you only see this heat flowing from the hot end to the cold end. Okay, so the question is, why does not this happen, even though it does not violate conservation of energy principle? Okay, so that's what the second law explains. The second law says why this process does not occur, and only this process occurs in nature. And what the second law does is introduces a concept of entropy denoted by S. And what the second law says is when this process occurs, entropy increases. And when this process, if this happened, entropy would decrease. So the second law states in nat processes where entropy increases occur in nature. Okay. So that's the second law of thermodynamics. All right, what I'll do is I'll pause now because I've introduced a few chapters. Okay.